Isaac Newton, the boy beneath the apple tree who changed the world. A quiet afternoon in the English countryside. A young boy sits alone beneath an apple tree. No friends, no laughter, just the wind, the shade, and a mind racing with questions. Suddenly, an apple falls, not onto his head, as the legend goes, but close enough to spark a simple question no one had truly asked before. Why does the apple fall, instead of flying upward? That boy's name was Isaac Newton. And from that moment on, he began walking a path that would reshape all of human understanding. From the motion of falling apples, to the orbit of planets, to the laws that hold the universe together. He started as a lonely, awkward child, and became the man who launched the modern age of science. The lonely child who watched the world differently. Isaac Newton was born on January 4, 1643, in the village of Woolsthorpe, England. He was premature and so small that no one expected him to live. But he did, and that frail child would grow into one of the most formidable minds the world has ever known. His father died before he was born. His mother remarried and left him in the care of his grandparents. Isaac grew up quiet, withdrawn, and deeply introspective. He didn't play with other children. He built windmills, sundials, and tiny machines instead. He wasn't the top student at first. Teachers thought he was distracted. But the truth was, Newton wasn't uninterested, he was simply uninterested in what they were teaching. One day, after a fight with a classmate who ranked above him, Newton became obsessed with beating him academically. He soon rose to the top of his class, not out of passion, but out of sheer willpower. Outside of school, he sketched the world around him with eerie precision. He wrote down experiments in secret. He invented devices using simple tools. By the time he was a teenager, he had designed a working water clock and a model wind-powered cart. But still, he was alone. His mind wandered to places no one around him could follow. He saw patterns in nature, wondered why the moon didn't fall, why colors separated through glass, why light behaved like both wave and beam. In 1661, Newton entered Trinity College at Cambridge. But just 3 years later, the plague forced the university to shut down. Newton returned home, isolated in the same countryside where he had once stared at falling apples. And in that isolation, something miraculous happened. Over the next 18 months, in what he later called his Year of Wonders, Newton laid the groundwork for the 3 laws of motion, the law of universal gravitation, and early concepts of calculus. He was barely 24. The boy who once watched apples fall was now seeing the entire universe move. Gravity, calculus, and the rise of a reluctant genius. Back in Woolsthorpe, far from the distractions of university life, Newton was free to think. And when Isaac Newton thought, he didn't just ask how things worked, he asked why the universe itself moved the way it did. Why did apples fall? Why did the moon stay in orbit? Could the same invisible force explain both? He began to develop what would later be known as the law of universal gravitation, the idea that every object in the universe pulls on every other object. The larger the mass, the stronger the pull, and the farther apart 2 objects are, the weaker the attraction. This simple idea would explain the fall of fruit and the paths of stars. But Newton didn't stop there. He explored light. In his darkened room, he passed sunlight through a prism and watched it split into colors. This shattered the ancient belief that white light was pure. Newton showed that it was, in fact, a mixture of all colors. He designed new types of telescopes. He built one with mirrors instead of lenses, an invention that avoided distortion and would later bear his name, the Newtonian telescope. And then came his most controversial insight of all, a new branch of mathematics. To describe motion, change, and acceleration, Newton invented what we now call calculus. He didn't publish it at first. He was hesitant, perfectionist, afraid of being misunderstood, and that fear would shape the rest of his life. In 1667, Newton returned to Cambridge and became a fellow. In 1669, at just 26, he was appointed Lucasian Professor of Mathematics, the same chair Stephen Hawking would hold centuries later. He lectured, but rarely drew crowds. He wrote, but didn't publish. For years, he held back discoveries that would later shake the scientific world. Why? Because Isaac Newton didn't crave attention. He craved certainty. He wanted to be right, not first. But in the shadows, he was building a framework of reality itself. He believed the universe wasn't chaos, it was order. And he was beginning to see the code. Principia, power, and Newton's transformation into a legend. In 1684, the brilliant mathematician Edmund Halley, yes, the one who discovered the comet, visited Newton in Cambridge. He posed a question that had puzzled scientists for decades. What kind of force keeps the planets in orbit? Without hesitation, Newton replied, an inverse square law. He had already solved it. Halley was stunned. He urged Newton to publish his ideas. After some reluctance and much persuasion, Newton began writing. The result would become one of the most important books in the history of science. Philosophiae Naturalis Principia Mathematica, or simply, the Principia, published in 1687. The Principia laid out Newton's 3 laws of motion. 1. An object in motion stays in motion unless acted upon. 2. Force equals mass times acceleration. 3. For every action, there is an equal and opposite reaction. These weren't just abstract rules. They were the mathematical skeleton of the physical world. They explained why things fall, why wheels turn, why planets orbit, why tides rise. Suddenly, the universe wasn't mysterious anymore. It was mechanical, predictable, governed by laws anyone could understand if they had Newton's mind. The Principia was revolutionary, but so was Newton's life. He became a scientific celebrity. Kings and queens consulted him. Scholars admired him. His name was spoken with awe. Yet, fame didn't soften him. It hardened him. Newton became increasingly secretive, paranoid, and obsessed with controlling how others interpreted his work. He clashed with rivals, most famously with German philosopher Gottfried Leibniz, over who invented calculus. Newton had discovered it first, but hadn't published. Leibniz had published first, but maybe discovered it later. The dispute turned ugly. Newton used his power within the Royal Society to discredit Leibniz. He was brilliant, but he was also human. In 1696, Newton was appointed Warden of the Royal Mint. He took the job seriously, cracking down on counterfeiters with a cold precision. He wasn't just a scientist anymore. He was now a man of law, power, and influence. By 1703, he was elected President of the Royal Society, and in 1705, he was knighted by Queen Anne. Sir Isaac Newton, the boy who once watched apples fall, now ruled the world of science. But behind the title, behind the prestige, there remained a restless spirit, one still searching for the divine order behind the stars. Secrets, alchemy, and the mystical side of Newton. While the world knew Isaac Newton as the mind who explained gravity, motion, and light, few knew what he was doing in the shadows. Behind closed doors, Newton studied something very different, alchemy. Yes, the same ancient practice of turning base metals into gold, searching for the philosopher's stone, and unlocking the elixirs of immortality. But for Newton, alchemy wasn't magic, it was a missing link. He believed the universe held hidden codes, and alchemy was just another language to understand them. He filled over 1 million words worth of notes on the subject, written in secret, using symbols, codes, and phrases from ancient texts. He pored over manuscripts by obscure mystics and medieval thinkers. He believed that God had left signs, not just in scripture, but in nature itself. Newton didn't see science and religion as enemies. He saw them as partners in a deeper truth. He wrote more about the Bible and prophecy than he did about physics. He calculated the end of the world based on the Book of Daniel. He believed that ancient civilizations had once understood the laws of the universe, and that he, through alchemy and divine study, might rediscover them. To the modern world, this side of Newton feels strange, even irrational. But to him, it was all one quest. To understand everything: the stars, the scriptures, the invisible forces, the patterns behind the patterns. Even his obsession with light wasn't just physical. He believed light had spiritual meaning, that it was the bridge between the earthly and the divine. In his later years, Newton rarely spoke about his alchemical or theological work. The few who knew called him eccentric or secretive. But some of his most enduring questions didn't come from telescopes or math. They came from ancient symbols, fire-stained parchments, and long-forgotten books. He died on March 31, 1727, at age 84. By then, he had become something more than a scientist. He was a mythic figure. Buried in Westminster Abbey, next to kings and queens, Newton's grave carries no formulas, just a Latin inscription praising the man who uncovered the mechanics of the heavens. But if you asked Newton himself what he was most proud of, he wouldn't say the apple, or the laws of motion. He once wrote, "I do not know what I may appear to the world, but to myself, I seem to have been only like a boy, playing on the seashore, finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." Isaac Newton gave us the rules that govern reality. But in his heart, he remained a seeker of mystery.